Hello, everyone, and welcome to our first webinar in 2020, the first AMS webinar. We are excited to bring you the latest module that we released, one of the latest and pretty exciting modules we released in 2020, which is the G-code editor. So we're excited to bring you that for this AMS webinar edition. My name is Joe Anand, and I'm the product manager here at MecSoft. I'll be joined today by Uday Honalagare, our support manager, will actually be doing the demonstration of the product, the module. But before we get started, as usual, we have a few housekeeping tips that I want to go over. The recording of this webinar will be made available to all the registrants, and we'll be sending out a link. It'll be a YouTube recording, a link that we'll be sending out once we clean it up and post it on YouTube. We'd like to keep this webinar as interactive as possible, but we typically also, if time allows, we'll reserve the last 10 minutes for questions. But please feel free to type in your questions on the questions window that's shown in the graphic here as the webinar is proceeding, and I will be in the background monitoring the questions, and I'll be trying to get to answer them as soon as possible. Or if we can get to it, we will definitely answer that by email offline. The next slide, please. Okay, today's webinar, as I mentioned, is going over one of the latest modules we released, which is a G-code editor module. Based on the response we're getting from our customers and also prospects, this is there's a lot of interest in this module, and we are really excited to bring this because I think we can add a lot of value to our customers with this module. And what the topics we're going to be covering today is basically going over the G-code editor, what it is and what it's not. Then Uday is going to be showing a typical workflow with the product, how we can load tool libraries and loading the tool crib, editing existing G-code files, and then also simulating the G-code, backplotting and simulating the G-code itself. And then some of the file operations that we have in the product, he's going to be going over those. And then setting preferences to allow you to maximize the efficiency of the G-code editor. And then finally, he's going to be talking about the limitations as well. This is our first release of the product, so we aim to continue enhancing this product as we go along. So please keep that in mind as you look at the limitation. This is not the end. This is our first release, and we will be enhancing it as we move forward. So we're pretty excited about this product. So without any further ado, let Uday take over here. Uday, it's all yours.
Thank you, Joe. Hello, everyone. Good morning, good afternoon, or good evening to you folks. And thank you again for joining us for the AMS webinar series for this year. And as Joe pointed out, today we will be covering the G-code editor module in our latest version of our MecSoft CAM products. So first, let's learn about what's a G-code editor. So a G-code editor is an editor where you can edit your G-code that you've generated from, ideally from a MecSoft CAM product. It also includes a backplot, a viewer, and you can run an animation as well as a cut material simulation. So it's just not an editor. In addition to it, you have more tools where you can view the G-code. So I'm going to switch over to Visual CAD CAM. And you can see that if you switch over to the G-code editor module, it's not just an editor where you can load the G-code. You can also view the G-code. You can backplot it. You can also run a animation and simulation. Now I'm going to cover all of this during our typical workflows, but I just wanted to explain what the G-code editor is. Essentially, it'll let you edit, make changes to your G-code, view a backplot of the G-code that you edited, and also run an animation and a cut material simulation of the edited G-code as well. Now, let's talk about a typical workflow. So now this is currently available in both Visual CAD CAM and RhinoCam, and the G-code editor comes included with a standard and higher configurations for customers who are active on their maintenance. So if you have standard, expert, professional, or premium and current on your maintenance, you will have access to the G-code editor module. So A typical scenario is you would be programming your toolpaths from the mill module. So in this particular example, I have a prismatic part, and I programmed a bunch of 2.5 axis operations. We have facing, roughing, hole pocketing, profiling, drilling, hole profiling, and then finally a 2.5 axis profiling. Once you have programmed these toolpaths, you would run a verification or a simulation in your mill module. So I'm going to right click and do a simulate. And the simulation, the cut material simulation that you're noticing here is based off your programmed toolpaths. Now, once your toolpaths have been programmed and simulated, you would be post-processing these to your CNC machine tool, CNC controller. So when you post-process these, you may have defined several additional parameters in your post-processor, depending on whatever post-processor you're working with. So the post-processing adds additional information, and you might be using different formats for arcs or helical interpolations and all of those. So in this particular step, I'm going to go ahead and post-process. And now we're going to use the G-code editor to verify and run a cut material simulation of the posted G-code. So you might have introduced some additional parameters which you wouldn't be able to simulate in just a mill module in here. So I've just post-processed the G-code. I'm sure all of our users are familiar until this process in here. So to switch from our mill module to G-code editor, you could select
I want to interrupt. I want to make one thing clear to our listeners. What we have in our mill module, what you're seeing, when you see the toolpath in the graphic screen in our mill module, or even the turn module or the other modules, toolpath generation modules, you're seeing what's an internal toolpath, the internal representation of the tool motions. That's what you're seeing. This is in no way representative of what actually goes to the machine. So what happens when you do the post-processing, we take this internal toolpath and go through a process of translation using the information that you have provided in the SPM or the post files. Using that information, we transfer or translate our internal toolpath into G-code. This process could potentially result in errors because whenever you do some kind of data translation, there's always potential for errors. And that's where the G-code editor comes into play. That's why there is a need for something like a G-code editor where you're actually looking at the G-code file to make sure that there's no errors in the translation, during the translation. So that's the real motivation for the G-code editor. I just wanted to make it clear as to when you look at both simulations, you might wonder why are we doing two simulations? So in this case, when you're looking at the mill module, it's actually simulating the internal toolpaths. When you look at the G-code editor module, it's actually looking at the posted G-code that's actually going to go out to the machine. So thank you, Uday.
Thank you, Joe. So once you have programmed and post-processed your toolpaths from the mill module, we would then switch over to the G-code editor module. So there's a couple of ways how we can switch. You can use the CAM menu at the top and then select G-code editor to switch, or you could even cycle through these menu options in here to go from mill to turn module. But to get to the G-code editor module, you just have to use the menu here and select G-code editor. So this basically replaces your mill interface with the G-code interface. So it has a browser-driven interface very similar to what you've noticed in the mill module. So the first step here is to go ahead and load the G-code we just post-processed. So I'm going to select the file, the one I just post-processed right here. I'll pick open. So as soon as the G-code, the NC file is loaded, you will see a preview, a backplot of your G-code itself. So this is the backplot of what the posted code looks like. Now, the next step is to basically define our stock. I'm going to select stock and then pick stock here. I'll do a cylinder stock so we can use this for creating a simulation, cut material simulation. So my stock has been defined. And you'll also notice that in this particular G-code NC file I've loaded, the NC file contains 4 tool changes. There's tool 7, tool 3, tool 8, and tool 1. So the tools that are used in the NC file is listed in here. So you also notice that there is a flag next to each of the tool because we need to load the tool definitions for each of these tools. So what does tool 7 represent? What is tool 3? It could be an end mill, a face mill, a ball mill, or a drill tool, depending on whatever you program. So the tool definitions, in order to load them, you would need a tool library to load the tool definitions to match each of these tools. So as you program your toolpaths in VisualCam or RhinoCam, you'd also want to look into exporting the tools. So you can use the same tool library that you used in generating your toolpaths. You can import the same tool libraries into the G-code editor. So you would go into load library and load your tool library. It's a CSV format, load it in, and you'll see all of the tools that you had defined and created in your library in the mill module are now loaded into the G-code editor module. And you can also filter these tools out based on the tool types. You have ball mill, flat mill, corner radius, tools for engraving, a chamfer, face mill tools, drill, and so on. You can also list all of these tools. Now,
Uday, I want to interject here a little bit. For those of you who might not be that familiar with how tools are defined in G-code, I wanted to explain that a little bit more. This might be overkill for a lot of you, but for those who are not familiar, typically in a G-code file, you do not have a definition of a tool. When I say a definition, it means the geometric information about what tool you're using. You basically have a tool number in the G-code. So when we load a G-code, all we have is a tool number. We don't know what size tool that tool number represents. So what Uday is showing here is the process of going and matching a tool number with the actual geometric definition of the tool by loading the tool library. So I just want to make that clear. Thanks, Uday.
Thank you. So once we have the tools loaded from the library, the next step is to add these tools from the library into your tool crib. So you would go into tool crib, you would then select add a station, and you want to add the tools that correspond to the ones that you have in your NC file. So you can see that there's tool number 7, 3, 8, and 1. So for example, if I go in here and select tool number 7, which is a face mill, and I pick OK, it adds the tool to the tool crib. And you'll also notice that now the tool definition of tool 7, number 7 is obtained from the tool crib. So the tool is fully defined. So I could go ahead and do the same process for the remaining tools. So I don't have to individually go and pick each one of the tools and identify from the list. I could simply click on add station and select all of these from the list. I can just use the shift to select all the tools, holding the shift key, and then pick OK. And you'll notice that the tools are fully defined. And also in this particular case, you're noticing that there's a duplicate tool number that's been added to the crib. So my library contained 2 or more tools that had the same tool number. So there's a duplicate. So we need to resolve the duplicate. So you will notice that here, station number 2 has a quarter inch as well as another tool in here. So you want to resolve it. So you want to make sure that the tool resolves. You delete the tool that's basically has a duplicate on it. So once the tools are fully defined in here, you're now ready to go ahead and simulate. So right click, simulate, runs your cut material simulation of the G-code that you posted. So selecting play, runs your simulation, and you can see it automatically loads a tool definition, and it switches as there is a tool change. And what you're seeing here is your cut material simulation of the G-code. Now, if you had not defined the stock, you could run an animation of your G-code without the cut material simulation. So I can switch back to the edit mode in here, and you can view the G-code. So that's the G-code that was loaded. And you can make changes. You can look at the information, which basically shows you the number of toolpath motions, the total estimated machining time, and the size of the G-code file as well. And finally, once you are happy with the result, you could go ahead and select output to send this out to your machine tool. So this would be a typical workflow. And if you like to make any edits, so for example, on this particular code, I'm going to add my program number to it. I can double click on edit to make changes or make edits to it, and then post-process it out to the machine tool. So if I select output, this basically outputs it and displays it in your text editor of your choice. So this is a typical workflow of how we would want to run the G-code editor. Now the next thing I'm going to cover here is how we can make edits to the G-code and also make additional file operations. Now for this, I will switch over to our RhinoCam product. And I'm going to go through the similar workflow here. So I'm going to switch to the G-code editor module. Now we can load one or more NC files. You're not just limited to loading one file. So I'm going to go ahead and click load. I'll pick a roughing operation. And I'm also going to go ahead and load a pocketing operation. So I have two NC files loaded in here. So roughing, backplot of roughing, and we have a whole pocketing operation. In the next step, I'm going to resolve, I'm going to bring in the tool definitions by loading in the libraries. So I'm going to load the tool library. And in this particular case, I'm going to pick tool number 3. And add it to the station. So I'm going to pick tool 3 from the station. So right now, I'm going to pick the tool number 3, which is the 3/4 inch end mill. And the tool is now added to the station. Now, there are several file operations that we can perform in here. So since these two NC files have the same tool numbers, I can merge these two NC files to one. I can select the two and click on merge. So in this process, we are combining the two NC files into one. So now I double click on it, and you will notice that the two files are merged into one. And in the editor, I'm going to make some changes in here. So when the two files are merged, I would probably want to go back and edit out the program end code so I can merge them. So the M30, which is a program end, can be removed in here. So I'm going to select these lines of code and also the tool call, right click and pick cut to delete these lines out. Now, as you make changes, the backplot is automatically updated on your graphics screen. You can use backspace to delete the lines. Like any other editor, you can make changes. And also you'll notice that the G-code editor is color coded. So you have different colors that represents for linear motions, for your rapid motions, for arcs. So they're represented in different colors. So it's easy. The text editor, the text has different colors in here. So you can easily identify what motions each of these are. And you can make changes to the G-code editor you can edit the G-code by editing the parameters in here. So for example, I'm going to change my linear motion right here. I can update my spindle speed if necessary. So I made a few edits to the code right in here. And also if you notice the line numbers, the sequence numbers, since we merged the two files, I would need to resequence these numbers in here. So I could delete the line numbers and just go back and add the line numbers to automatically have it updated. So this will update the line numbers automatically. You can also delete spaces and insert spaces in here using the G-code editor. So you can create, update the G-code, and once you're happy with the changes that you made, you can select save, and this will automatically update your NC file. And when you switch back to the project, you'll notice that the file has been edited. You can also insert program numbers in here by specifying your program number and select save to save off the changes. Now, once you have made these changes and updated them, you can look at the information, which gives you the updated information of your machining time and the total file size. And then you can define your stock material. to go ahead and run a verification of the cut material simulation. So as you notice here, the line numbers were automatically resequenced after merging the two NC files. And we've inserted the program number. And if you'd like to add additional comments, you can just insert a line to add additional comments to your G code. Now, I'm going to cover another scenario where you would wanted to instance toolpaths. For example, if you would like to make multiple copies of the same part, you could perform this under the file operations, like how we did the merge file. We could now use XY instance. Now, those of you who are familiar with our mill module, in the Pro configuration, you have the XY instance feature. We also have similar features in the G code editor, where you can specify the spacing between each part and specify the number of additional copies in X and Y to perform an XY instance. So we now have a total of 4 copies of the same toolpath. So you could use the file operations in here to perform a transform, an XY instance. You could also do Z instance if you need to instance the toolpath in the Z, and I'll cover that in another example. So in this particular case, we performed an XY instance and we specified the spacing between each part. So you can use the G code editor to perform an instance of your toolpaths as well. Now the G code editor can be used for editing and simulating both 2 and 3-axis toolpaths. The next example I'm going to be covering is on a 3-axis operation in here. Folks, if you have any questions, please feel free to post those questions in the questions panel.
I'm getting a lot of questions Uday, so continue.
Okay, thank you. So I am pulling up Rhino and RhinoCam. So as my Rhino session is being loaded, I will be taking up an example for a 3-axis part. So as you can see on this particular model, we have programmed 3 different operations, a roughing and 2 finishing operations. And I'm going to go ahead and run a simulation, a cut material simulation in our CAM product. And anytime you can select pause and pick simulate to end to run through the simulation. So I'm just going to skip through the simulation for each of these operations in here. So the toolpaths have been generated and simulated. I'm going to go ahead and post-process these out. And I'll choose a post-processor in here. I'll pick the Fedal as an example. And we have the posted output file right in here. Now I'm going to switch over to the G code editor module. We'll load the G code. And as you notice here, you might be wondering why the G code backplot displays strange arcs. Now there's different ways how arcs can be output. In the post processor, you have the settings for arc output. So the arcs, when you're outputting in IJK format, the arcs could be output as absolute arc centers, or it could be incremental arc centers. And in this particular case, we have it set to vector from center to start to center, which is an incremental arc center. And the output for the G code could have been set to absolute in the post processor. So when we change the output to the correct format, this should display the arcs correctly in your backplot. So I will be covering the preferences for the G code editor at the later part of this webinar, but I just want to show you how we can correct the output format to be displayed for your G code. So we wouldn't know when we load the G code, we wouldn't know what the arc output format is unless you're always posting it using the same post processor here. So in this case, the Fedal post is set to use absolute arc centers, and we change the preferences in the G-code editor to display arcs or circles with absolute arc centers. So now that we have loaded this G-code in here, I'm going to go ahead and load the tool library for it and add the tools to the crib. So the tool definitions have been loaded from the tool library. We will now go ahead and run a simulation of the G-code. So it looks like I have not defined my stock in here. So what you're noticing here is just an animation of your toolpath. So when the stock is not defined, what you're seeing is just your animation of your toolpath. So I'm going to go ahead and stop it, switch back to the project mode, define my stock. We'll do a part box stock. And now I'll go back and run a simulation of it. So I'm running through the cut material simulation. So you have the similar controls as what you have in your mill and turn modules for the simulator. Pause, play, simulate to end. And as it simulates to the G-code, if you take a closer look at the cut material simulation, you will notice that the G-code shows a gouge on the simulated part, which we didn't notice in the simulation that we ran in our mill module. So it looks like there's something that's been introduced in the G-code that's causing the tool to plunge down in the Z to Z0. So if I go ahead and take a look at this code here, I can see a couple of motions in here where it's going to Z0 right here. So I'm going to go ahead and remove the Z0 motion. So you can use the G-code editor to verify and see if there were any errors that you may have introduced in your post processor, either by manually inserting them in the post processor at certain program start and end codes or the tool change macro locations. So we can search through the code in here to find out, identify them. So I can right click and select for the next tool. And you'll notice that before a tool change, we had a G0, H0, Z0. So the Z0 is causing the tool to plunge down in Z and resulting in a gouge. So now that I have corrected those two motions, if I go back in here and run the simulation, it should fix and resolve those two gouges that we noticed in this simulation of the G-code. So the G-code editor is a great tool for you to validate your G-code output file before you send this code out to your machine tool. And you can identify and catch errors that you may have introduced in your post processor. So as you can tell in this particular step, we are no longer seeing the gouge where the tool was plunging down into Z to Z0. With the G-code editor, you can also search for tool changes. So you can go from the first tool to the next tool. You can right click in the editor and select tool. So it'll automatically jump to the location where the next tool is in the code, and also previews the tool that's being used. You can also do the same to search for a feed rate change. Right click feed rate. Will show the next feed rate change. You can do the same for a spindle. So it takes you to the next spindle change or spindle speed output in the code. So the right mouse button click menu allows you to search and advance through it. And once you make any of these changes, when you go back to the project, it's going to flag the NC file as dirty if you made any changes and are not saved it. So selecting save will automatically save the changes that were made to the G code, and selecting output will now output the code with the changes that you had made to it. Now the next thing I'm going to go over here is how we can use a Z instance operation in the G code. So for this, I'm going to go ahead and load an NC file. I have a curve machining toolpath that's been programmed and output. So I have a curve machining toolpath. This toolpath generated in our mill module, the toolpath is following the surface. And if you'd like to cut deeper into the surface to create an indentation, you could use the Z instance option and specify the Z spacing. So I could say I would like to go down 25 thousandths, and I want to do it in 2 passes. Set the number of instance to 2 and select OK. This basically creates 2 additional passes. If you edit the G code, you will notice that as you step through the code, you'll see it creates 2 passes. The first pass is on the surface, and the next pass cuts 25 thousandths below the surface. So you can use the file operations commands to perform Z instance of your toolpath. We've already covered the XY instance earlier in one of the examples where we had a prismatic part with 2.5 axis toolpaths. So the Z instance can be performed in both 2 and 3 axis toolpaths. And selecting save will save these edits, and output will output the code with the Z instances. Now the next thing I'm going to cover here will be the G-code editor preferences. So I'll go ahead and load one of these NC files in here. And as I double click on the NC file, it displays the G code. And we'll go into preferences. The user interface preferences allows you to display the context sensitive tooltips. And also you can choose a ribbon style in here for the display. You have different themes that you can choose from. Now the text editor has different colors. You can set the rapid motion color. By default, it's set to red for rapid motions, cyan for linear motions, arc motions are in dark blue, the line numbers in gray, and then the comments are in blue as well. Now you can change these colors, and this will be automatically updated. So for example, if I change the color of the arc motion and pick apply, this would update the editor with the changes in the color as you noticed it right here. So you can pick and choose the colors that would be most appropriate for your use. You can also set the output file. So by default, it's set to Notepad. So when you post, when you save and then select output, the output file is being displayed or output in a Notepad. If you want to use your own editor of your choice, you can send it out. Or if you want to directly send it to your controller, you could specify the file name and the executable path for this, and it'll automatically display it in that particular program for you. Now, as far as the
can you bring up the dialog again? It's not the file name; it's actually the program name. That's all you need to specify. Yeah, in the
sorry.
Yeah, all you need to do is specify the program name that you want the G code to be loaded. Very similar to our CAM products. So if you're running a controller, you want a controller software to consume this G-code file directly, you can put the name of the controller executable file here. And if that controller software can read a file name as a command line input, then it will automatically load the G-code file that you're post-processing from here. So it can be very useful. Thank you, Uday.
Thank you, Joe. So this basically would be the application that you want to use to send the output to, if I may be correct. So the next option is the toolpath option, the colors. So this is in the viewer, what you're looking at the back plot. You can set the colors for your toolpath for the rapid motions, the arc motions, and the cut motions can be specified in here. And as you see, these are the default colors. Arcs are represented in dark blue. And you can also set the display thickness for the toolpath. So you can increase or decrease the thickness of the toolpath that's being displayed in here for the back plot of the G code. And then we have the circle format. We noticed that when we loaded the code, the G code back plot of the arcs looked strange. That's because we had it set to one of the other formats. So if I pick the format to vector from start to center and pick apply, you'll notice that the arcs are being displayed based on the I and J values are being displayed based on vector from start to center. But this particular G code that we have loaded uses absolute arc centers for the IJK parameters. So you'd want to pick the appropriate circle output format. Now you can verify what is set in your post, and you can use the same settings in here in the preferences for your G-code editor. Now, if your output contains radius only, then the circle center IJK wouldn't make a difference, because whatever format you have it set, it's basically the radius format will have just a GO2 or a GO3 with X, Y, and radius, so this wouldn't apply. You can also specify a feed rate speed for the rapid and the nominal cut motion. So these will be used when the information for the machining time is estimated for the rapid feed rate. You could specify this. So for example, if your rapid feed rate is going to be, the controller is set to 100 inches per minute, you can specify the rapid feed rate right in here to 100. You can also specify the nominal cut feed rate. So these are for the motions that do not have a feed rate assigned in here. So you can specify a nominal cut feed rate and apply these. And this will be used when it estimates the total time, machining time. And then we have preferences for the display of the stock and the cut stock color. Similar to what you've seen in our mill and turn modules, you have the same controls. The stock model transparency can be set to either opaque or transparent. Your cutting tool colors, the tool color can also be set for the cut material simulation. And in the simulation preferences, you have the option to set the simulate either by moves or by distance, and you can adjust the simulation accuracy. Now there's a few things I would like to go over here is some of the current limitations in our G-code editor. So the type of files, the G-code files that we can load and we can backplot and simulate are currently limited to NC files or G-code files, which means if you have a file that's in standard G-code format, like for the one example in here, this particular one is in a standard G-code format, we can support these, and then we need to make sure the arcs are in the right format. We wouldn't be able to support files that are not in the standard G-code format. For example, here I have a G-code output that was output for a Heidenhain controller. And as you can see, these are not in standard G-code, which doesn't use GO1 or GO2 or linear rapid motion in the standard G-code format. So these are currently not, we wouldn't be able to support those. Also, machines like Roland's, which use RML, which is a proprietary format, which is RML Roland Machine Language. We will not be able to support these formats. So anything that's a standard G-code format, NC, text, tab, which is in a standard G-code format, can be supported.
Yeah, one other thing I wanted to explain as well is these are the present limitations. We do have a roadmap for the product to be able to handle different formats, different G-code flavors, as well as different formats. And one of the things that we definitely will do is to what we call reverse posting, using the same post processor file that you use to post process. If you do have RCAM products, we would be able to reverse post using the same settings of the G-code back into the G-code editor. So a lot of this information can be saved and displayed. So those are all in our roadmap for this product. Thank you, Uday.
Thank you, Joe. Also, with our current limitation, we will be able to, work with 2 and 3 axis outputs. Multi-axis is currently not supported in our G-code editor module, which means 4 and 5 axis are currently not supported. And also, turning is not supported yet in the G-code editor. So if you're using your mill module to program 2 and 3 axis outputs, you will be able to, and the output is in standard G-code format, you will be able to load those G-codes and perform backplot, animation, and also cut material simulation and make those necessary edits. Folks, if you do have any questions at this point of time, I'll be more than happy to take that. Joe, I pretty much covered all of the topics that we had planned for today's webinar.
Okay, all right, thanks, Uday. So as you can see, this is a brand new module. We're pretty excited about this. And so if you have any enhancements that are near and dear to you after seeing this and after running it, please do not hesitate to contact us to support and let us know what is most important for you, so we can get those implemented ASAP. And as you know, you are our AMS customers, our maintenance customers, our valued customers, so your enhancements do come have priority, top priority. So your voice needs to be heard. So please send us email or whatever way is comfortable for you to contact us, and then we'll go from there. There's a few other questions. Okay, it's the statistics. Uday, can you show the statistics page, the information about the G-code file? See what we can display at this point. They want to talk about that, where to access that, and
absolutely. So I could select information under the file operations menu on the project tab. Click information. It'll display the name of the all of the NC files that you have loaded. List the tools that are used in each of these NC files, the total number of go-to motions that you have on each of the G-code files, the machining time, and the size of each of these files. So I hope this answers your question.
The other questions that came in is, will the G-code editor alert you of a collision? At this point, we don't have collision detection yet, but that's some of the things we will be adding. We'll be adding holder collisions and things of that sort pretty quickly. So those are things that are planned. Okay, we got a few requests for enhancements. We'll definitely consider those in our planning. So if you don't have any other questions, I think, Uday, this might be a good time to wrap it up. The first time we've actually not gone over our allotted time frame. So thank you all for listening. And you can contact us by phone, fax, email, or Skype, or chat window as well in our website. So thank you again for joining us, and please do communicate with us on your wish list and your enhancements. And I already see a few out on the questions window, so we'll definitely make sure they get prioritized. And thank you very much.